Hello guys, I hope you are doing well. In this video, we are gonna continue our conversation and our discussion about limits. We did a previous video about limits where I presented the intuitive notions about limits and what they mean without really going through the mathematical formalities and the equations, etc. So in this part we're gonna took a little bit of formalities. It's not the complete formal theory about limits, but just halfway there. So let's start. First of all, let's talk about some conventions that we're gonna need to introduce limits. So we must define at first the set R bar, which is equal to R union minus infinity and plus infinity. This set contains, sorry for this problem, this set contains all the known real numbers and two more quantities we call plus and minus infinity, because in R we don't have that plus infinity and minus infinity. They are just intuitive notions. Well, it's the same in R bar, but we treat them like numbers. So we have the rules of calculating in R bar. It's practically almost the same as with R. So for sums we have if we have n and l and real numbers, then the sum of them is just l plus n. If we have, for example, a different case which is n plus minus infinity, this gonna gives us just minus infinity. We say that we neglect n compared to minus infinity, then the same goes to plus infinity. N plus infinity gives us plus infinity. So if we take a look at the second row, we have here minus infinity plus L, which gonna give us just minus infinity. Minus infinity gonna give us minus infinity, and minus infinity plus infinity, we call this an indeterminate form, because we don't know what it's gonna give us, minus infinity or plus infinity or zero or another number, because it's just like having a lot of money, for example, and someone takes a lot of money of that money you have, so you don't know which one is bigger or which one is less. So we call it an indeterminate form, and in the next slides or maybe the next video we're gonna see how to deal with this when we have limits. So we have here the third row, plus infinity plus L gives us plus infinity plus infinity minus infinity. It's just the same as plus infinity minus infinity plus infinity and indeterminate form. Sorry. And finally plus infinity gives us plus infinity. So now moving to products, we have n times L gives us L n times L, and n times minus infinity gives us minus the sign of n times infinity. So if n is positive, this is gonna just say minus infinity, and if n is negative, this is gonna gives us plus infinity. Just like the rules of calculating products in R. Minus times minus gives us plus, minus times plus gives us minus, plus times minus gives us minus, and plus times plus gives us plus. The same here goes with plus infinity. N times plus infinity gives us plus the sign of n infinity. So if n is positive, we're gonna just get plus infinity. If n is negative, we're gonna get minus infinity. The same here with minus infinity times L. It depends on the sign of L. Minus infinity times minus infinity is plus infinity, as we just said. Minus times minus gives us plus. And minus infinity times plus infinity gives us minus infinity, because we have minus times plus, which is minus. The final row is plus infinity times L, just plus the sign of L times infinity. If L is positive, we're gonna just get plus infinity. If L is negative, we're gonna get minus infinity. And plus infinity times minus infinity is just minus infinity, following the same rules of signs and multiplication. And plus infinity times plus infinity gives us plus infinity. And we have other indeterminate forms. We basically have to write another table for division, but it's almost the same with products. So if we have 0 divided by 0, it's an indeterminate form. Infinity divided by infinity, it's an indeterminate form. And 0 times infinity is an indeterminate form. So if n here is 0 and we have n times 0 times minus infinity, that's actually an indeterminate form. So let's now move to limits. We have first a definition. Let f be a function defined in a domain df. Our domain of definition, we're gonna call it df. X is in df, and let x0 be an df bar. Df bar is, if we take for example r bar, we're gonna get our known r bar. So df is just a way to include the boundaries and the limits of our domain. So we say that f has a limit L on r bar on x0 if f of x gets closer to L when x gets closer to x0 for every x in df. So to understand this definition, we're gonna take an example. So if we write the limits of f of x when x gets closer to 2 equals 5, this means that when x gets closer to 2, f gets closer to 5. Let's try and... So if we take this as the x-axis and this as y-axis or f, so we said that when x gets closer to 2, so if we take this as 1, 2, 3, etc., our f of x gets closer to 5. So if we take this as 1, 2, 3, 4, let's take 5 here. So when x gets closer to 2, which is this, our f gets closer to 5. So our f will be something like this. When x gets closer to 2, our f gets closer to 5. And the same goes here if we approach from the right side. The same with when the limit goes to infinity of f of x, we're gonna get if the limits of f of x when x goes to infinity equals 0, this means that when x gets bigger and bigger, f gets closer to 0. In this example, our f gonna be something like this, and it gets closer to 0 when x gets bigger. Now let's move to left hand and right hand limits, as we just saw in the last example. So we either gets closer to our x0 from the right hand side or from the left hand side. So from here we are getting closer from the left, and from here we are getting closer to the right, from the right. So we define the limit of f in x as the value of f when x gets closer to x0. This should be x0, I'm sorry. to x0, but we didn't determine from which side. A specific direction, we get a left hand or a right hand limit depending on the direction. A clear example is the limit when x goes to 0 plus to 1 over x, which gives us plus infinity. But on the other hand, the limit when x gets closer to 0 minus of 1 over x, it gives us minus infinity. So we are switching sides. Why we have here plus infinity and why we have here minus infinity? If you remember the last video, we said that here we calculate how much is 1 over x when x gets closer to 0 plus. So we calculate, for example, 1 of 0 1 1 divided by 0 0 1 1 divided by 1 over a million, etc. And it keeps getting bigger and bigger. However, here if we have, for example, 1 divided by minus 0 1, it's gonna give us minus 10. And if we keep going like this, we're gonna get minus 10, minus 100, minus 1000, etc. So it gives us minus infinity. So let's move to the rules of calculated limits. So let f and g be two functions x and df intersection of dg, the intersection of the two domains, and x0 is in the intersection of the two domains bar. So let L and M be an R bar such that the limit of f of x when x gets closer to x0 equals L, and the limit of g when x gets closer to x0 is M. We have then the following rules. The limit when x gets closer to x0 of the sum is just the sum of the limits. The limit of the product is just the product of the limit, and if k is a real number, then the limit of k times fx is just k times the limit of the function. If g is different from 0 around x0, then and the limit of g of x when x gets closer to x0 is different from 0, then the limit of f divided by g is just the limit of f divided by the limit of g, which is just L over M. As we said, M is different from 0 here. So let's take some examples. The first example is the limit when x gets closer to 0 of x squared plus 2x plus 1. So as we said, it's just the sum of the limits. The limit of the sum is the sum of the limits. So it's gonna give us the limit of x squared plus the limit of 2x plus the limit of 1. So this is gonna give us 0. Just replace x by 0. It's gonna give us 0 plus 0 plus 1, because we don't have x here or anything, so just 1. So the limit is 1. Another example is the limit when x gets closer to 1 of x plus 1 over x squared plus 1. So this one is, as we said, just the division of the two limits, and we replace, for example, here x by 1, which is gonna give us 1 plus 1, and the same goes here. 1 squared is just 1 plus 1 equals 2, so it's just 2 divided by 2, which is equal to 1. A third example is the limit when x goes to plus infinity of x squared. This is gonna give us x squared minus 2x plus 1, which is just the sum of the limits, but this time this is gonna give us plus infinity minus infinity plus 1. As we said before, plus infinity minus infinity is an indeterminate form, so we have to figure how to calculate this otherwise. So we have here the limit when x gets closer to plus infinity. This expression here factorized by x squared, we're gonna get x squared times x squared over x squared minus 2x over x squared plus 1 over x squared. So if we multiply here by x squared, all the x squared here gonna disappear and we're just gonna get our first function. So we try to simplify these expressions. It's gonna give us the limit of x squared times 1 minus 2 over x plus 1 over x squared, and we can calculate this because we know how to calculate a number divided by infinity. It's just 0. So we're gonna get here plus infinity times 1 minus 2 over infinity plus 1 over infinity squared, which is gonna give us just plus infinity times 1 minus 0 plus 0, which is gonna give us plus infinity. Another example of indeterminate form or indeterminate forms we have here the limit when x goes to infinity of x plus 1 over x squared plus 1. So this is, we just gonna replace here infinity here and infinity here, and we're gonna get infinity over infinity, which is an indeterminate form. So what we do is we factorize again, factorize here by x, and we factorize here by x squared, and we calculate the limit again. We're gonna simplify by x here and x here, so the x here gonna disappear and we're gonna get just x here without the square. So this is gonna give us 1 plus 1 over infinity times 1 plus 1 over infinity squared. So this is just 0. This one also is 0. So we're gonna get 1 over infinity, which is 0. Another example is the limit when x gets closer to 1 of x squared minus 1 over x minus 1. Sorry, this is just x. There is no 2 here. So x squared minus 1 over x minus 1. So this is gonna give us the division. We divide the two limits, which gonna give us 0 divided by 0, because here we replace x by 1. So it's 1 squared minus 1, which is 0, and here 1 minus 1, which is 0. So how can we calculate this? We should try and get and do another trick to find the limit. So we know that x squared minus 1 it's just x minus 1 times x plus 1, you know, the known identity, divided by x minus 1, and we simplify here by x minus 1 and here x minus 1, and this gonna give us just the limit of x plus 1 when x gets closer to 1, which is gonna give us 2 because we replace x by 1. Thank you so much, guys. I hope this was useful and understandable. Once more time, I'm sorry for the quality of the sound and the perturbation. I'm trying really hard to work on it, and I try to get a new microphone soon. So I hope you enjoyed, you understood what we're talking about, and you had fun. If you have any questions or remarks, you can put them in the comment section. Don't forget to give me a thumbs up and subscribe if you like our content. Thank you so much.